Water flows at the rate of 10 meter per minute through a cylindrical pipe of 5 millimeter in diameter. How long would it take to fill a conical vessel whose diameter at the base is 40 centimeter and the depth is 24 centimeter? First thing first, we'll need a diagram. So we have quite a few things to convert in terms of units. So we have a pipe. Then we have, just a second. Yeah. Then we have a cone which has been filled. Now we are looking at the radius and rate of flow and all of that. So we have the radius over here. How much is that? This is diameter. So this would be 5/2 millimeter. That would be a radius. And here the radius is, diameter is 40. So this will be 20 centimeter. And the height here is, and the height here is 24 centimeter. No, yeah, 24 centimeter. Okay, and we have the water that is coming out of the pipe at a rate of 10 meter per minute. So let's look at the unit. So this is in centimeter, centimeter. So let's convert all of them to centimeter. So this is 10 to the power of 3 centimeter per minute. I'll show you how to do this. And this would be, I'll write it over here itself. This would be 5/20 centimeter. Okay, all the units are good. And now we have the working. So let me show the given first. So first we'll start off with rate of flow. So that is equal to 10 meter per minute. So we know that every meter has 100 centimeter. So 10 meters will have 1000 centimeter. Agree? And so this is nothing but 10 to the power of 3. And that's why I wrote this as 10 to the power of 3 centimeter per minute. Again, this is only for your understanding. You guys can write it directly. Okay, then we have the radius of the pipe, which is equal to diameter by 2, which is 5/2 millimeter. But we know that every millimeter is 0.1 or 1/10th of a centimeter. I would like to express in terms of fractions itself. So this is 5/20 centimeter. Okay, then what else? I think we are almost done. Yes, only these two. And now the working. So which begins with writing the required formula, that is volume of the water, or how do I okay, the funda is quite simple. The time that takes into the volume of water that comes out of pipe every minute will give us the volume of the cone. Right? That's the whole idea, is it not? So again, remember, we are talking about water that's coming out every minute, or we can just tell water that's coming out of the pipe. Okay, so let me rewrite this. I can go it in another way. Do it in another way being this. See, whatever volume of water that comes out of pipe, that has to be equal to the volume of the cone. That's the funda. Now, what is the volume of the pipe? It's basically a cylinder, so it is pi r square h. And the volume of a cone is 1/3 of pi r square h. But since we are talking about two different things, this subscript has to be added. Right? So this is your funda. Just stick to my method. There is one more way of doing it, but that's a bit complicated. The only complicated thing over here is compared to other method, and that too I simplified it by putting a formula. The height or the length of the kennel can be obtained with the rate of flow into time. So here I have the rate of flow into the time. This is where the time factor comes into picture. Okay, so we know the rate of flow, we know the radius, here radius and height, everything is known. Substitute it and we are done. So once more I'll explain the height of the pipe. What does it mean? See, we don't know exactly how much water should come out, right? If we imagine this pipe to be infinitely long, okay, so we're looking at water that is coming out, say after 2 minutes from here, say here, 4 minutes will be over here. Water that is 6 minutes away is over here, 8 minutes away is over here, 10 minutes is away over here, and so on and so forth. So how much water should come out is the length of the pipe. Okay, again we are imagining it to be infinitely long. So using this funda we'll be able to solve this. So we have pi and pi getting cancelled. The radius over here is 5 by 20 into 5 by 20 into the height is rate of flow is how much, guys? 10 to the power of 3 every minute into time. See, this is how we get the time, and this is 1/3 into radius over here is 20 into 20 into 24. 20 into 20 into 24. Okay, let's see if I can cancel few things out. Okay, let's see this now. So we have 3s are 3s are 24. Yes. Then we have 1s are 4s are 1s are 4s are. Then we have t is equal to 20 into 20 into 4 into 4 into 8. A lot of things to be multiplied, divided by, this is 1 2 3,000. So we have 10 10 10 10, all of this getting cancelled. Okay, I think we are almost done. Okay, everything looks good. Okay, so what do we have? We have 2 2s are 4, 4 4 16, 64, 64 into 8 by 10. So as usual, 8 cube basically. I don't remember 8 cube though. So this is 1.2. 0.2, so it will be, how much is it in terms of seconds? 0.2, so many minutes. Okay guys, so 0.2, wait, 0.2 will be how much? So 1 is 60 seconds. So 0.2 will be, no, wait, we are looking at, let me think of it. Yeah, right, that's it. So should I be doing this first of all? That is 30 seconds. How is that possible? 3 seconds. Just a second. Wait, x into 1. Okay, 1 minute. No, what? Okay guys, this is 0.2. Yeah. Oh yeah, 12 seconds. That makes sense. Okay, anyways, this is good enough. I just wanted to check this out. Don't worry if I kind of confuse you guys. That's not required. This is enough. And this would be our answer. So here again, the funda is over here. The height wala picture has to be understood. So I'm just equating the volumes and then substituting the formulas, and the height will take care of the time. Again, there are different ways to approach this. They talk about how much water is coming out every second. I go with how much water is coming out for this time. So if I have to find time, I'm multiplying with t, so on and so forth. Okay, so this method, you can stick to this method and pretty much do all the questions. There's no confusion. Only place here is, in place of height or length, you have this and you're done. And that I made it clear over here, so you guys have something to remind before your exams as well. Okay, so now you can pause and have a look at the answers.